Hello everyone, welcome to this session. My name is Saeed Ghaderi. I'm a PhD student at the University of British Columbia. In this presentation, I'll talk about 3D printing of pH-mediated high water content hydrogels for electromagnetic interference shielding. As you know, 3D printing techniques have been used extensively to process different materials to reduce harmful impacts of electromagnetic interference waves. In this presentation, we used polyacrylic acid hydrogels to extrusion-based print shields and structures as EMI shields. As you can see here, different concentrations of polyacrylic acid have shown different viscosity, which the hydrogel containing 4 weight percent of polyacrylic acid, which is known also as carbomer, show shear thinning behavior with the highest shear viscosity and also the highest viscoelastic dynamic moduli, and also the highest shear stress and yield stress. We extrusion printed these materials and these hydrogels. As you can see here, 4 weight percent of polyacrylic acid hydrogels form a uniform filament which can be printed in different structures and geometries. The obtained structures and printed hydrogels are highly transparent. We evaluate the electromagnetic interference shielding effectiveness of these structures and printed geometries, as you can see here for the sample with 100% infill with the thickness of 1.6 millimeter. The EMI shielding effectiveness around 18.6 decibel was obtained, which it means that almost 99% of the incident wave dissipated through the materials, and we obtained like almost similar results for printed samples with different grids and different size of opening and gaps. These high EMI shielding effectiveness of because of the presence of water inside the shields, and because we validated based on the dried samples, which was less than 1 decibel for the dried samples without any water content. As a conclusion, polyacrylic acid hydrogels can be used as EMI shields in different applications, especially in or optical transparent applications. They can be printed in different geometries, different structures, and they can retain their shape after printing, and printed structures show the high EMI shielding effectiveness. Thank you everyone for your time.